Yo, yo, yo. What's up, what's up? Welcome back. Today we're working on my operating system titled StreamOS. It's an operating system that we're developing on Stream. It's an x86 operating system written in Rust. And I know, for whatever reason, that's what we're doing. It's fun, I guess, by some metric of fun. We have like some form of useful behavior, so it's starting to be like presentable in some way. If I run my little demo, I get a virtual machine that pops open. This is a QEMU virtual machine. In here, I can see my paddle moving when I hit A and D on the keyboard, playing this like little demo game, which proves that we have like drawing to the monitor and keyboard input working correctly. We also have like a web stack, so if I open up my browser over here and I go to the IP of the kernel, we see hello from StreamOS kernel, and if I like punch something in, he punches something back. Great. What we're working on for the past few days is USB support. So we have a mouse that we want to get working, and we've kind of implemented a bit of a like USB demo, we should call it probably. So we can definitely like see movement of the device. If I get into my logger here and move my mouse around, we can see that there's like stuff being spit out here into the serial console, and QEMU is forwarding the serial console output to our terminal, so it looks kind of like a normal application. But yeah, we can see like as I move the mouse around, I can like click and I see 1, right click I see 2, press on both I see 3, and if I move to the left I see like negative numbers in the X, and if I move to the right or move up and down I see negative positive numbers in Y axis. And so what I wanted to do today was I wanted to like create like a mouse driver so that we could get to the point where if I move my mouse left and right, I want to see the paddle move in our little brickbreaker game. I think that's like a pretty good demo and like a good like tie off to this series of USB work. And so the question becomes like, well, what do we want to do there? So we've kind of like just got everything running under this like UHCI, which is a like USB thing. We'll get to that later. We've got this demo function, and we're kind of like assuming that there's only one thing plugged in, and that the only thing that could be plugged in is a mouse. And eventually, like what we actually are going to want is we're going to want like a mouse driver that is like struct mouse, and probably on him we're going to have like get position or something, and he is going to return like, you know, his like X and Y positions, right? And so the question is like, what is this guy going to look like? Well, he's going to have like some probably understanding that he's USB, and he's going to have some sort of way to like, he's going to have to like keep track of the fact that he needs to pull the mouse every once in a while, and he's going to have to keep track of like the mouse movement versus position. And so the question becomes like, well, how the hell are we going to model that? And so I thought would be kind of fun is if we start by like looking at the Linux kernel for inspiration, and then come back and implement something. Maybe it looks like what Linux does, maybe not. It totally depends. The current mental model. All right, let's just kind of like line up what we know about like the USB stack and how maybe that will guide our implementation in some way. So everything that we are running code-wise is running on the CPU. He has a like PCI bus that is connected to something that they call a USB host controller. This guy has like USB ports on him, boop, 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 boop. And one of these is plugged into our mouse. This guy also goes through, like, has direct access to, like, memory in our system. This would be physical memory. In our case, we've sidestepped, like, a normal operating system has, like, the concept of virtual memory and physical memory, and those two things are, like, not compatible. Well, they're compatible. They're different. Virtual memory has like addresses that map to physical addresses, but they don't have to be contiguous, etc. Anyways, the point is, this is physical memory, and we've sidestepped a bunch of the like complexity around physical memory for now. We'll probably have to come back to that later. And so what happens is in our case, we're talking to a UHCI card. UHCI is like a specification that was written for USB 1.1, like 1.0 or 1.1 or something a long time ago. We're on USB 3 now. We're living in the Stone Ages on my operating system. And it's like a protocol that basically defines what I expect to see here and what I expect to see here. And like, I guess here as well. Right? So it's like, how are we going to talk to this guy? And there's a bunch of like setup and initialization stuff, but like the core of USB is like interacting with the mouse is that we give him a list of stuff to do, right? We say like, here is a list of stuff. And what's going to happen is every millisecond, details omitted, right? He's going to look at a segment of work and he's going to say like, I'm going to spend 1 millisecond here, 1 millisecond here, 1 millisecond here. And these pieces of work can point to queues of work. So what we end up doing in our driver right now is we have like one master list of work, which is called a queue in their nomenclature. Is that his like naming system? And what we do is just point every millisecond. He's just going to point to the same queue of work, right? Every millisecond, he's going to check if there's any work to do. And we like kind of just like append work with these like transfer descriptors is what they call them in UHCI world. Which will have like buffers of USB packets as well as some like metadata to figure out how to like put things onto like this line, right? We put metadata into this descriptor to say, here's how you're going to talk to the mouse. Great. What else? Each of these, each thing that gets plugged in here, like if we had a keyboard over here, they're going to have like a unique address that we have to assign it. So each one will start with address 0. We turn them on one at a time and we go like, here's your address. Yeah, okay. So why are we going through all this? Well, there's kind of like three layers of stuff here. One is like mouse or keyboard. These guys should know that they are USB devices, but they probably shouldn't care about like this USB controller card that we're talking to. That's like a really like low level implementation detail for the driver for the mouse. But what they do care about is they know that they're USB. And just to clarify, there's like a bunch of different types of host controllers. There's like EHCI for USB 2, XHCI for USB 3, OHCI for like USB 1, but like if you were developed by like somebody that wasn't Intel. And so like then there's like a USB subsystem because like no matter what host you have here, these messages are still the same. And from the perspective of the CPU, we're gonna like packetize like a USB message that says like setup, and we're gonna try to like send that to the device. And we don't really care about the details of like how it gets to the device. We just know that we want to send this data to this device, and we know that we want to like get data back from the device. So these guys should talk to like this USB layer, probably. I'm not really sure. We'll see. And the USB layer would like on a more flushed out system probably talk to like different code controllers. So you'd have like UHCI driver, EHCI driver, etc. And like maybe you have multiple UHCI cards on the same, but like, you know, plugged into different PCI slots, whatever. Probably like these guys just want to know that they talk to USB. And then USB kind of handles the like dispatching to different hosts and whatever. And so this is kind of like how I assume that things are modeled. It's kind of like what the OSDiv wiki kind of hints at, as well as the Linux kernel, I think, does something like this as well. I have like some like questions about how I want to implement this. Like things like what is plugged in? Right now, that knowledge is like pretty obvious here, right? We say like the UHCI card, it will just tell us when something's plugged in. You can say like, hey, you have a port 0. Is there something plugged into port 0? And he's like, yep, sure fucking is. Here you go. This is the thing. And then we like construct some USB packets and we say, hey, can you like check what that thing is and maybe like set its address? And so like we have this kind of like confusion between like, well, there's stuff that we need to initialize at like the USB layer, but there's also stuff that we need to do at like the host controller layer. And how are we going to separate those? How are these things going to be propagated up to the mouse keyboard? Not really sure. And so that's why I wanted to take a look at like what's in the Linux kernel. That will give us like some clues as to like what works on a fully fleshed out system. And we might not do what they do, but it will at least like show us what we would need to do to get to a point where everything would work with like a million drivers, etc. So that's what I think I want to do first. Linux driver inspection. Okay. So before stream, I just set up a little development environment for Linux and set up like an indexer. So I think it's kind of interesting. This stuff's pretty cool. So usually getting indexing in a project, like especially like a C++ project, like sucks. Like I usually struggle with it pretty hard. But this one was actually pretty easy. So I got like with Nix, I just like asked it for a Linux environment. I was like, hey, could you like give me the packages that I need to build Linux? Then I installed clang-d, and there's this like handy little script in the Linux kernel. I think it's in clang tools. There's this like gen compile command script, and this basically says like, hey, look at all the things that you built when you built the kernel, and turn that into like a database of commands that I think like pretty much any IDE at this point we'll look at. So we have like, I know that like VS Code does it by default. I have my NeoVim set up to look at this like compile commands. And then now when I like go and look up like UHCI and I look at like host controller driver, I do have like indexing here, which is pretty sick, right? Like I can like jump to this guy, look at what he is, whatever. Pretty handy. Okay, so what do I want to look at? I know that I'm working with UHCI, so I just like scan the Linux repo for UHCI, and I see like, oh, well, there are things like, I'm not really sure what any of these are, but I can probably guess that HCD might stand for host controller driver, so that's where I was starting. It does say host controller interface, so we've got a pretty good clue that this is where we're starting. Linux kernel drivers, they kind of start in like, they kind of have like multiple stages here. How do we describe this? There's like, they have like init, which is like, here is my kernel driver. This is like, register my driver with the Linux kernel. So this part doesn't actually set up any devices. It just says like, hey, I'm a driver that could set up devices if I needed to. Then there's like probe, which is now like initialize me essentially. So like they do this thing where since all of your like kernel drivers are optional to some extent, right? You could compile them out. They might not be compiled in. We like iterate over all of the things that have been registered at compile time with this like initial to be initialized, and then we initialize them, and then when there's like drivers that they attached to them, then they probe them, if that makes sense. So like this is like detected UHCI PCI card, call probe with PCI device. This is like do stuff that needs to be done to probe for probe to work. Yeah. So here we are looking at like the initialization of the host controller driver and hoping that we can like glean some information about what they do. So they like, what do? They say like, hey, we have one. They set up some like kernel memory. It looks like according to my indexer, this stuff isn't run. That's why it's grayed out. And then they say PCI registered driver. So this is probably the interesting part. They're assuming that the PCI driver is a PCI card. And what is this guy? This guy is like a bunch of functions, right? Well, maybe not functions. We don't actually know what these are. Ah, fuck. It looks like this isn't indexed properly. Probably because they include one C file directly from another C file, and this like my indexer probably doesn't know how to deal with that. So I think, yeah, if I try to like jump to definition on anything here, some of it will work, a bunch of it probably won't. But that's okay. Okay, so what do? So they say, here is my driver, and I have like a probe function, I have like a remove function, I have a shutdown function. And here is like a list of PCI IDs, probably. Yeah, here's like a way for you to determine if this PCI card is a UHCI card. So probably the interesting part, if we're trying to figure out like how are they like managing devices versus host controller devices versus USB, whatever. This is probably the interesting part to look. So USB HCD PCI probe. They define it here. And what does this guy do? Creates a HCD. So it looks like they have like a common host controller device concept, probably. Where's this guy used? He's used in... Yeah, okay. So in all of the like different types of cards they can work with, OHCI, UHCI, EHCI, XHCI, they all implement, I'm assuming, we'll see, we'll double check this, that I think that they're all going to implement this like common USB host controller interface. So here they like allocate the like common thing. And then they do some like checking. Is like, does it have bugs? Does it need like some like memory allocated? Or maybe it's like telling it if it needs some memory allocated. Not really sure. None of this is really what I'm looking for right now anyways. Okay, and then they like register the controller with the USB system as a whole. Makes sense. And what do they do here? They like say, I'm registering a USB bus that is myself. What's going on here? They like set up some like interrupt handling if and only if it's the root one. Sure, whatever. Probably this like bus thing is the interesting part. Because I would assume... Maybe we should look from the other end as well. I think I saw somewhere they also had a USB mouse driver. And this guy, I think, if I remember correctly, is doing something very similar to what I want to do. Is he checks if there is a boot interface, which is what we want to use for our USB mouse polling. And he says, like, register any boot interface mice with me. So someone probes this guy with a USB interface already set up. So that's interesting. And he has this like ID table, which says like, here are the IDs of things that we care about. So probably someone in the USB system is going to like probe a device, look at its ID, and then call me if I need to. Yeah, it does kind of look like they have this like match ID function. So what's going on here? So this is in USB probe interface. Who knows what that is? I don't. This comes from... I see. So when I registered my USB driver, which I think we saw in the... Did we see that in the UHCI stuff? Hold on. HCD PCI probe. I think it was USB. Did we see that here? He said USB registers something. Oh, he said add host controller. Maybe in the mouse we saw the driver add. USB mouse. So they had a probe function. Did they have like an init function? No. Init? There's got to be an initialization somewhere. Nope, no init. Okay, so they just... Oh, here we go. Module USB driver. So this guy probably registers... Yeah. So this guy registers this guy as a USB driver, which does this like USB register function. And this calls USB register driver, which is where we are here. Okay, so we register the mouse with the USB subsystem as a USB driver. And then when we probe him, we check the IDs that he might match, and if they match, probably we do something with that. Then we call probe on him. Cool. Okay, so that already is giving us like some mental model of what could happen. Here is in the Linux system, they have a USB system, and it is responsible for matching devices to drivers. And each driver says like, hey, I am available if with these sets of rules. If we look at like the USB mouse, what's kind of interesting here is this matching is not based off of like device. So, well, let's see. Interface info, interface class, interface subclass, interface protocol. Yeah. Okay. So what I was a little confused about when I was coming in today is the OSDev wiki USB. I just want to reference a photo in here. Please be up to date, please. We've been struggling with the OSDev wiki recently. Yeah, it's down. Archive, web, archive. Let's just try to get an old version just for reference. Sure. Give it a sec. Let's go pull it up. Come on, buddy. Come on, come on, come on. Okay, here we go. Okay, so there is... Where do I find this? Here. Okay, so the idea of a USB device, USB, they call devices functions. I'm not really sure why. I didn't really read too closely. I'm impressed it still exists. I was using it in the early 2000s, really 20 years ago. But damn, that's crazy. It's still very useful as far as I can tell. Maybe I'm 20 years behind, but most of the things I've read on there seem pretty, like, I do what they say and they seem to work. So that's pretty cool. Pretty cool. Okay, so USB devices. They're called functions, but they're devices, whatever. Interchangeable. They have like multiple configurations, and in these configurations, a device might have like multiple interfaces. And interfaces have endpoints, and endpoints are what you talk to. And so I guess the idea is that like a function is like the thing you plug in. So I might have like a merged keyboard mouse. Actually, I do have one of those, right? Like say I have this guy, right? He's got like a mouse on him as well as a keyboard. So you could imagine maybe you have a function, this merged keyboard mouse, and maybe it implements multiple interfaces. It could also be implemented as like a USB hub that has two devices on it. But like say it is implemented as one device that has multiple interfaces. You could have like the keyboard interface and the mouse interface. And so what I wasn't sure of when I was thinking about like how am I going to like lay out my drivers was, should I be matching against interfaces or devices? And should my like mouse driver, does it own an interface or does it own a device? Like I don't really know. And so it's kind of cool to see that like this USB mouse implementation is matching on interface, not on device. But I think I also might see here that the fact that they flag this as an interface info, I don't know if that means that it has to be an interface. They might be like the USB system might allow us to match based off other stuff. Let's see. Let's look at this. Like, what are they doing when they match IDs here? Match device. Yeah. I see. So they either match by device here, or they match by interface here. So you have the option when you create your USB driver, to either match by device or interface IDs. I'm not really sure if the owner of this thing becomes the device though. Like if this guy has an interface, multiple interfaces on him, I don't know if the it looks like this match ID is going to give us the whole device either way, I think, depending on what interface here means. USB interface could mean an actual USB interface, or it could be mapping to the USB model of interfaces, or they could be calling interface something else. I'm not really sure yet. From memory, Linux allows matching by VID, PID, etc. Where V would be... Sorry, I don't actually know what VID or PID means in this case. I'm thinking about PID as the, like... I've seen PID to refer to packet identifier field, but I don't think that's... Oh, vendor ID and product ID. Ah, yeah. Yeah, I think... So that is what we're seeing here, I think, is that they're saying you can match by vendor and product ID if you're matching by device, vendor and product, or they're allowing us to match by interface, which here they're saying, like, I want to match by I'm like a human interface device with the boot protocol and a mouse. Okay. So if he matches it, he probes, and he probes with an interface, not interface and device ID. Okay. So say I am my mouse driver. How do I like talk in the Linux world? Sorry, let's go step back a second. So the way that the mouse works, as far as I understand, is it has like an interrupt endpoint on him, which essentially means once you've figured out who you're talking to, you can skip some of the like extra overhead that would normally be associated with asking for data, and you can just say, I will assume that when I read data from you, you will give it back to me. And so basically, like, the mouse will say, hey, I would like you to poll me at like once per n milliseconds, and we're supposed to like put things into the queue at that rate. And that's like a USB level concept, but you could it is implemented kind of at a UHCI level as well, right? Like with these queues of work that we were talking about earlier, where each of these things happen like 1 millisecond at a time. What you can do is you can actually take like every 8 of these, so you can say like 1, 2, 3, 4, 5, 6, 7, 8, and you could point this to like work 8 millisecond, and then you could like put things that you want to be pulled every 8 milliseconds on that queue of work, and they would like automatically happen once per 8 milliseconds. I wonder if they're doing something like that here. So here in the mouse driver, let's see if there's anything interesting here. So they have open and close. They have device registration as an input device. USB int fill int URB. Oh, okay. This is probably what I'm looking for. Macro to help initialize and interrupt URB. Yeah. So here they're saying it looks like the USB subsystem, I'm guessing, is saying, hey, inject a URB, I'm assuming is like their way of talking to the USB card at like an abstract level. Let's just double check that. Your USB request block. Let's see. Oh, sorry, I want to look at usages of this guy. Aha, yeah. So I'm seeing a bunch of usages in the controller card stuff. So here, I'm seeing, UHC queue up this URB. So probably what's happening is, in that mouse driver, we were saying like, make me a USB request block, which is their like abstract concept of like a packet in some way, probably. And these guys are queued into the UHCI subsystem, and in the USB mouse, they were asking for an interrupt controller, and they're saying, when you finish, call this callback. And he is responsible for submitting him again. Okay. So I see. So the USB request that we give to the USB subsystem must encode how often he wants to be polled. Yeah, he's just like injected in here. And then probably when we like queue this into the UHCI subsystem, the UHCI subsystem goes like, oh, let me check how often you want to be polled, and I'll like dispatch appropriately. So probably actually, if we looked for usages of that interval flag, we can probably find in the UHCI driver somewhere where they dispatch appropriately. UHCI. Oh, fuck. We see that actually everywhere except in UHCI, which is interesting. But we know that the UHCI poll, how do I say this? The UHCI indexing, we already kind of noticed was fucked earlier, so there's a chance that it's still in there. Let's just look up interval. Aha, yeah. Okay. Figure out which power of 2Q to use. Okay, cool. I think that actually has given me enough of a picture to piece together what they're doing. So it looks like what they're doing in the Linux kernel is... Oh, the only thing I'm missing actually is how do they notice when a device is plugged in? We could probably guess, actually. So probably what happens. Maybe I draw like a sequence diagram here. That's probably the way to do this. So we probably have like UHCI, USB, and mouse, right? These are kind of like our three layers. Probably what happens, hand wavy. UHCI notices that something's plugged in. So we'll say like dev plugged in. He somehow flags up to the USB subsystem. It could be either USB like calls something on him or he calls something on USB. He says, hey, I got something plugged in. USB probably, actually I should probably double check this. I assume, this could be wrong, this could be done here, but it makes more sense to be done here, is USB like constructs like setup packets. Like, hey, like, what device ID are you? And here, like, let me set your address. And what interfaces do you have? Are any of those any of the IDs I've matched before? And he'll send those back to the UHCI controller. UHCI controller, like, actually sends those to the device. And then he sends back the response. So we'll say, like, TX and RX. So now he knows like which his devices, etc. He then, probably at some point before this, the mouse driver registered with USB and he said, here are my IDs. Here is like the rules for like when you should call me. The USB subsystem goes like, oh, I have the ID now. ID. And he goes like, oh, I've seen that before. The mouse guy, he asked me for it. And so then he like calls like init or construct or whatever on the mouse. Then the mouse driver is probably responsible for setting up interrupt packets. So he's going to say like interrupt packet stuff. He's going to forward it over here, and then when the packet is finished, he's going to send it back. And then the mouse driver like loops back to here. I know that this isn't legible at all, but and like I think that we've got a bit of a picture. Basically, like UHCI is only responsible for a little bit. The USB subsystem is responsible for like converting like requests of stuff into something that is like common across all host controllers. The host controller takes that common thing, puts it in the appropriate spot, and the USB subsystem is responsible for like detecting which drivers are available and dispatching them appropriately. Seems reasonable. So now the question is what the fuck do we want to do in our operating system? Right now, everything is there's no like separation of abstraction here right now. Everything's just happening at the UHCI level. And so, let's think. Beep, boop, beep, boop. What do we need? We need a way for the UHCI subsystem to flag that there are things plugged in to a USB system. We need a way for the USB system to queue things into the UHCI system to talk to devices. And we need a way for drivers to get loaded for specific devices based off of what the USB system detected was there. I think that's pretty reasonable. So I think I'm going to change gears here. Oh, hold on. Something very important is missing. We don't have our maze. It must have crashed. Okay, but we're also going to switch gears here. And we're going to say we're about we're 37 minutes into stream. Or 30 minutes into stream. And we want to implement some form of UHCI abstraction. Hold on, just let me get this guy in the right place. So keep above others, no child bar and frame, line them up, baby. And we kind of do this. Okay. Yeah. So I think probably in terms of like UHCI flagging to USB, what's going on, I think it's probably pretty straightforward to just, we could have like a feature that notifies us when something is plugged in. So we could have like pub async function wait for device, and he will like eventually return. Maybe we say wait for port. He doesn't actually have to return anything because from the USB system's perspective, we know that any device that is given to us will always start with address 0. So we can say like wait for plug in. Then what else are we gonna have? We're gonna have like queue. We're gonna have like this like some way to like do work, send packets and wait for their responses. Which I think we actually already have that. We already have this like append work function somewhere, who takes in a bunch of like work to do and converts the like gives back a future that will tell us when it's done. So we can probably just adjust that a little bit to match up to what we want. Where did my dummy functions go? I lost them. Here, wait for plugin, or wait for, maybe we say like port status changed, or yeah, port status changed. And I guess we could have like an insertion or removal of a device, but whatever. And so what's this guy gonna do? He's going to wait for a interrupt probably from the UHCI card. But I think maybe we can cover that later. Maybe the initial thing that we do, the easiest thing we could do is just not support hot plugging. And we will just assume for now that on boot, all USB devices are plugged in for the lifetime of the operating system. That'll make our lives a little easier. And so then we can just say like iterate ports. And this guy will return what? I want to say like an iterator, but I think that you can't have future iterators. I think I've seen this concept of like a future stream in Rust, which says like, I think it just is like an iterator, except the next function is like a future. Let's see. Futures, I think in docs.rs is probably where I want to go. So I think they have like something called like a stream. Yeah, and they just have a poll next method on them. Oh, that's interesting. So who calls poll next? Probably this guy has like impl future for stream or something. How the fuck does this work? Future. Because like somebody has to call that poll next on him, and I assume that that has to be a future for it to work at all. Impl stream for poll immediate. Not sure. Okay, but anyways, the point is they have like their own iterator class thing. Future async competition. Yeah, okay, so probably what we'll do is we will create a iterator that is not really an iterator. That's probably the easiest thing to do here. So we'll say struct UHCI port iter, and we will implement UHCI port iter, and he'll have a function on him next. That's just like an async function, and he will return an option something, option port. I guess he'd actually just has to tell us when something is plugged in. There's nothing about the port that we care about. We just want, how do I say this? Because the consumers of this guy will always just assume that the thing that he found is at address 0. So it'll just be an option of nothing. And we'll figure out what to do in him later. So this guy will return a UHCI port iter. And he's also unimplemented. I think we should compile still. Nice. Okay. So now, on initialization, what's going to happen? We're probably also going to want to have, like, source USB. We're going to have, like, a USB subsystem. Actually, I'll avoid making that for now. We'll do everything USB still in the UHCI file for now, just so that it's easier. Eventually, we'll have to fix that, but it's okay. So let's make a USB system. And what's he going to do? He's going to be, like, he's going to have the stuff that we need to, like, construct packets and stuff. Is he going to have any state associated with him? He must, right? He's going to have, like, address. He's going to have, like, an address book. Like, which addresses have we handed out to USB devices already? But maybe for now, we can assume that we only have one. Sure. So he's going to have, like, next USB adder. And we're going to say, like, we're going to construct him. And he's almost certainly going to have to look at the UHCI stuff. We could maybe argue that he should take UHCI by reference. But maybe he can own the UHCI thing because nobody else really cares about UHCI. Nobody should be working with UHCI directly. They should only be working with him through USB. I guess theoretically you could have multiple UHCI cards plugged in that we found. But maybe for now we just assume there's only one. That makes our lives easier. Eventually, in the future, we might have to take care of that, but for now we can just ignore it. And which means that when he finds a UHCI device, instead of the kernel owning UHCI, which he does here, he could own a USB instead. And so here, when we walk PCI devices, we find our UHCI, but then we say let USB is equal to USB new, and we pass in UHCI. Okay, and then here we need to pull in the USB system. Okay. Private associated functions. This is public now. And this is unimplemented. I guess it's not. It's this easy to implement. We have next USB adder is 1 because 0 is reserved and UHCI is just passed in. Cool. So now the question is, well, first let's make sure that we've pulled anything that's using the UHCI system now. It just goes away. We don't need that anymore. And now the question is, what do we do here? So here we're gonna iterate over the ports. So we'll say here, let ret is this. But before we return, we're gonna want to look over the ports that we have. So we'll say, sorry, I'm thinking. So we have UHCI. And we're going to look at the iterate ports. I guess this should actually be port iter, not iterate ports, because it's not actually iterating them, it's returning an iterator. And I guess this guy is going to take in himself by mule reference, almost certainly. And here we'll say, next we loop, we say let item is equal to iter next await. Right, because this is like something that is asynchronous. Is it? I guess not. When we are plugged in initially, since we're not waiting for something to complete, we're not like waiting for something to get plugged in. We know what's being plugged in our model because we don't care about like hot plugging right now. There's no async here, so that actually makes our lives a lot easier. So this, we can say impl iterator for the port iter. This guy, we can just say implement missing members. This guy should actually do the port initialization. Oopsies, I just lost where I was. UHCI port iter. This feels a little misleading name-wise, but we'll deal with that maybe later. That's okay. So here he'll say, for nothing in UHCI port iter. This isn't an async function anymore. We need to make this mutable. What's he gonna do for each port? Well, here we have like the setup stuff in our demo function. Where are we? Here. We like reset the port, which we don't have to do. But here we have like actual USB stuff. So he tries to set an address, he tries to check the descriptors, and he tries to set their configuration. So I guess here he's going to iterate the ports. He's going to look up which ports have which IDs associated with them, and then he's going to call the mouse driver, initialize the mouse driver for the appropriate one. So, sorry, just let me think about this. Okay. So for each port, I think we only set the address. That seems reasonable, right? Because later we will be using this USB subsystem to like look for addresses. We'll be iterating over the things that we found and matching those to device IDs and then instantiating the driver based off them. So here, all we're going to do is we're going to set the address. So say self UHCI. We'll call this USB. And we'll say USB UHCI set address on that port. And we're going to set the address to let address is equal to USB next USB address. Now this is async, and it has to be because doing USB work requires like waiting for things to complete in the hardware. And so the question is do we want our like new function to be async? Because that's going to cause like a problem in our initialization. Right now, we assume that our initialization is done synchronously. But I guess there's no reason that we couldn't do it async. Yeah, that doesn't seem crazy. So maybe we put all of this in an async function. And hold on. Let me just make sure that everything compiled before this. Close. So here we're missing here a just little brackety thing. Here we've got an accidental borrow. Interesting. Oh, here we need to do USB.UHCI. And this probably has to be like mutable. No. Yeah, maybe this feels mutable. Yeah, there we go. So now I think we compile. Great. And so now the question is like, how do we make like our initialization of the kernel async safe? So I think we just write async here. And then here, we'll just make an executor. And we will spawn kernel init. And then we'll get the kernel back. Now, I think our executor actually doesn't have any way to return the output, which is kind of annoying. But that's okay, because what we can do is for now, we could say let mute kernel is none. Then we make an async block. And we say what? Kernel is equal to this. And then we spawn kernel init. Like this. I think. And then we run it. Cool, and then we can say let kernel is equal to kernel dot expect failed to init kernel. What doesn't it like here now? It doesn't like that the async block is not send because const_u8 is not sent. Oh, that's so fucking annoying. Oh, it's so fucking stupid. Fuck. Because this like multi-boot info that we pass in is a const_u8 and that's not safe. So we just say type multi-boot pointer is, I guess make a struct multi-boot pointer, which is just a const_u8. And we just say impl send for multi-boot pointer. And then I think that we can just say that let info is equal to multi-boot pointer info. And we pass that info in, and the kernel info just needs to take a multi-boot pointer. Okay. What's next? Borrowed value does not live long enough because kernel is dropped here while still borrowed. So we have no guarantee that this guy is like finished running at the end of this. That's so fucking frustrating. That is frustrating. I guess we just need a like shittier version of our executor. So right now we have like an executor that spawns multiple futures and he like runs them, blah blah blah. But I guess we just need a like really shitty version of this guy that just like runs a future and blocks. It's like essentially the old version. I guess the question is do I want to go down this road of making our initialization asyncable? It would be nice, but if this is the only guy that needs it, maybe there's another way to do it. Maybe the USB service should walk the ports after it starts. That seems reasonable. And it also kind of lines up with the idea of like ports being hot pluggable later, right? Really, we shouldn't be enumerating ports at this point in time. We should like when we see something get loaded, when we see something plugged in, then we load the driver for it. Ugh. Fine, we'll do it right. Fine. Okay. Cargo check. Let's just make sure we're in the right state. Yep. And so I guess what we'll do here is in our USB system, we will make a service function. Struct USB like this. Pub async function service. Takes himself. And here he iterates the ports. And does the like USB address stuff. And the question is like, what does he do with that after? So once he set the address, he gets the configuration, sets the configuration, and then probably must like read the device ID or the interface ID and send him up to the mouse. I don't really want the like this like driver registration thing that the Linux kernel did. Like I don't want the USB system to know about mice, right? I think what I want is for the kernel as a whole to walk USB devices and dispatch as it sees fit. So probably what that'll look like is we are going to like ship off these like devices just like out through a channel probably to the rest of the kernel. That seems reasonable to me. That seems reasonable. So how is that going to look? So here we are going to run our USB service. Let's just quickly check that that's working. Okay. And what's going to happen here is we're going to, for each device that we find, we'll shove him into a channel. That seems reasonable. And then our kernel will then initialize our mouse based off of that, I guess. So we'll say late init, or we'll say like USB driver dispatch is an async block. And what's he going to do? He's going to have some sort of handle that he needs to get. So the USB will probably be like device channel. He's going to give him back something. A like receiver of USB devices. And the question is, what the fuck is a receiver? Do we have a channel type right now? I actually don't know. So we have like a lock-free queue, but I don't really want that. I want like an async channel. Oh, we do. We have async channel. Perfect. So here we'll just use our implementation of an async channel. So async channel, and here we'll have channel, sender, and receiver. Yeah. I'm liking the way this is starting to pan out. So here we have a struct of USB device. We don't know what's gonna go in him yet. Doesn't fucking matter. And this is unimplemented for now. So here we're gonna say let device rx is equal to self.usb.device channel. Now, our channels, if I remember correctly, are multiple sender, single receiver. So here we're going to say that our RX is an option receiver USB device. And for now, we'll just say that like it's invalid to call this more than once, right? So we'll say core mem take mute self.rx. Right, so if we call this a second time, it'll fail. And expect. Can only run device channel one time. There we go. Okay. So we'll say TX here is a sender of USB devices. And then we say let, I think TXRX is probably the order, is channel. But I don't like using these like channel directly. We should be saying async channel like this, and then here we should import self. And here we pass in RxTX. Great. Here we need to wrap this in a option, so we say like this. And we're chilling. We're chilling. Okay. So in main, what we're going to do is, like, once our kernel's up and running, we're going to run this USB service, which will iterate the ports. When it finds something, he'll send the device out. Here, we're going to say, well, when we find a device, we have to check if it's a mouse. And if it's a mouse, then instantiate our mouse driver. So here we could say something like, what's our, like, I don't actually know what the API on this guy looks like. Async channel. So he has a receiver. And he just has receive. Sure. So we just have an infinite loop. Say let device is equal to device rx.receive. And then we'll have some sort of like check if device is a mouse. Then we like instantiate the mouse with this device. So that means that our kernel must have like a mouse device that could be instantiated. We'll say that probably maybe what happens is we start with no mouse, We pass like a handle to like, but we know that we could have a mouse. So probably, let me think about this. We could say that in our kernel, we have like mouse, right? And then, or sorry, option mouse that starts as none and then eventually gets populated. But then the question is like, well, won't other people care about the mouse? Like our game, for example, will want the mouse. And like maybe not. Let's see what this looks like for now. I guess, yeah, we'll see how this looks. So for now, we'll just set up our kernel to pull in this like mouse thing that we haven't really written yet. And somewhere here, we need to use mouse. And then when we initialize our kernel, we just say mouse is nothing. Okay. So I think we compile again. We should still compile. We're close. Let's just delete this guy. There we go. Okay, we're still compiling. Good. Good. Okay. So now, here we're gonna like check if the device is a mouse, and if it's a mouse, we'll say self.mouse is equal to some mouse new device. Which means that this guy needs to have a public function new that takes in a device, which is a USB device, which means that we need to use create UHCI USB device. We have no idea what the fuck this is going to be yet, but we're just kind of stubbing stuff out and seeing where the compiler takes us. Here, we'll just say mouse. I guess here we can assume that we'll hold on to the device. Okay. So what doesn't he like? Cargo, check. Found future, I see. Mouse new, so here we just need to say await on this guy. Okay. So nobody in there is mad yet, which is good. That's actually surprising. I'm surprised that, oh, because nobody's running the feature. Probably if I run executor.spawn USB driver dispatch, there's almost certainly going to be a problem with this, like a lifetime issue. No. Okay. That's surprising. So I thought for fucking sure, the fact that I'm assigning in here would break some sort of like mutability guarantees of the kernel, but I guess not. That's actually really surprising. Like, wouldn't making 2 of these be like totally invalid? Oh, interesting. So maybe it knows that I'm only borrowing the mouse. Like if I say like frame buffer. Yeah, interesting. Is it let me do that? Cargo check. Oh my god. Bad example. We'll say self.serial. I just want to like prove that I can do something. I'm just trying to prove that the compiler, yeah, oh, okay. That's interesting. So I guess that the compiler is smart enough to know that the mouse is the only thing making it into this block, and so it doesn't need the whole driver to be mutable. Although we will still run into problems, right? Because here in our game, we're certainly going to want the position of to be put there. But maybe let's think about this. I wonder if like sorry. So we could either the game could own the mouse, right? Or the mouse could provide updates to whoever's listening. And that kind of makes more sense. So I wonder if like probably what this will end up looking like is we'll pass in like let input updater input rx is going to be something. And we'll put like input tx as like something that we give to the mouse. And then the mouse can just write that. And then we can have something valid for the lifetime. So I think that'll work. I think that will all work fine. And then probably we're going to want to like... We'll also probably want to be like servicing the mouse driver in some way. So we'll say like service mouse service. And so maybe it actually makes sense to do something a little wild here. And use a channel again. Right? Because like you could imagine a world where we also have like keyboard service, right? And so if we wanted to do both of these things at once, having this guy like handle the service doesn't really make sense. But also, we only have one driver at the moment. So like, let's not complicate things. So I guess here we're just gonna say pub function service. He's gonna take himself in by mule reference. And we don't know what he's gonna do yet. But he's also probably gonna need to use the USB subsystem here. Or at least have some mechanism of like sending messages to the USB system. So maybe we'll figure that out in a minute. Well, I guess he is going to have some sort of service. And so here we can just say self. We can say let mouse is equal to mouse new device. And we'll then just run mouse service directly here. Eventually, there's going to have to be more intelligent dispatch than that, but I'm not really worried about it. So it's going to be an async function, and we need to declare this immutable. Okay. Sure. And we'll figure out the rest later. So now the question is what the fuck is the mouse driver actually going to do? He's clearly going to talk to this guy. So we're going to have some sort of like some sort of function to queue work. And he's going to take in a bunch of USB packets. Now, the problem here is that packets can have like multiple types. So we can't just take in like work as a vector of U8, like as like a bunch of packets to send. Right? We can't do this. Because we need to know like a little bit of extra metadata about this, like where is he going and what type of packet is he, etc. So maybe it makes sense to do something similar to what the Linux kernel was doing when we looked, and we can have a struct that's like USB packet. They called them request block. I'm going to call it a packet for now. Maybe that's incorrect. And we're going to have things like the like type of like what is it? So I think this is called PID, and I think we have this somewhere already. I think. Yeah, this is already what we want. Like setup in or out, like are we writing, are we reading, etc. What else are we gonna have on here? We're gonna have the address. We're gonna have the endpoint. And we're gonna have data. And I guess probably when we have like already a function to generate a transaction descriptor, and we can just look at what does this guy take in? He takes address, endpoint, PID, buff. So that's actually exactly what we have here. Perfect. So here he's going to take in a bunch of packets. Okay. Then we can just, for each of these guys, call generate transaction descriptor, which is like the UHCI mechanism of it's the descriptor that we give to the host controller card that will tell him what to send to the actual device, because then he's got to like wiggle some bits and shit. And so we can probably just modify this guy to take in a USB packet. And everywhere where it says that there's a compile error now, we can just say packet. Oopsies. So this is buff is packet.buff. No field buff, so this is actually called data here now. These guys have packet and address and packet endpoint. And this is packet PID. Okay. And so now all the places where this guy's called, we actually have to fix them up, which is going to be annoying, so I'm actually just gonna I'm gonna avoid fixing this for now and just take the old API and convert it. Because that'll make it easier to move on now. So before we had address, endpoint, what was it? Address, endpoint, PID, and buff. And we'll just make this be the same thing as this. And we'll just say generate TD USB packet. Address, endpoint, PID, data. Gross, but it is what it is. All right. And so now all of these guys that are complaining about generate TD not having the right things, we just say generate TD raw or something. Where raw is a very bad name for this, I'm very aware, but it's temporary. Because all of these guys who are calling generate TD directly shouldn't be anyway. So this is just a temporary measure, so we can keep compiling and move on. Okay. Okay. So now when in our USB system, oopsie, struct USB space. That's how we find it. When we queue some work, we just say for packet in work, we'll say let UHCI work is equal to vec, an empty vector. I guess with capacity of the work vector size. It's a slight optimization. Then we say UHCI work push generate TD packet. Expect failed to jet queue work. Now this should probably be a runtime error, but I'm just gonna make a compile time for now. Or sorry, it should be this shouldn't be an assertion, but I'm allowing it for now. I am allowing it for now. Say invalid USB packet, whatever. Then we run the work. So we say self UHCI append work. We give it the work, and we await it. And then we need to convert this back. So this guy is working at the like UHCI level, and so we just say, what do we want back here? We want vec of vec u8, I think. Right? This guy's gonna request some data, and this guy's just gonna give him back what the device said without any of the metadata. I think that makes sense. So here we'll say finished work dot, I guess this has to be a vector of boxed vectors, probably. We'll see. We'll see. Maybe this is fine. So here we have finished work. We map the item to item.buff. We collect it. Into iter, sorry. Okay. That's all great, it looks like. Cargo check. Yeah, everything is working. Okay. Easy peasy. So now we have like a thing that the mouse can call into. Looks good. I wonder if there's anything like that will fail now. I think that we're maybe in a spot where maybe what we'll do here is our mouse service temporarily will just print the mouse position like we were doing before in our demo. Right? So down here, we were saying, we were just looping and waiting. So let's just see what happens if we try to do that. USB packet. This is unfortunately, I don't know if this is right. Okay, so when I send multiple things in a row, boom, 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 we have to alternate a bit so that the controller knows that it's like doing things in the right order. I don't really understand fully why, but it's something about synchronization and like serializing and stuff. So we say like left, like number 1, number 0, number 1, number 0, number 1, number 0. And I don't know who I want to track that. It kind of makes sense for the mouse driver to keep track of it. So for now, I'm just going to say data toggle is a Boolean that gets set in this guy. And when we pass him on down here to generate TD, this guy's going to say data toggle is always 0 because anybody who's calling him from within is manually setting him after. But here, down here, we're going to say ret descriptor set data toggle to packet data toggle. Great. Okay. So now, we can construct our packets based on what we see. So struct USB device. This guy is going to take inside him, he's going to have a address, a endpoint. Maybe this seems kind of sketchy. It seems like maybe the mouse driver should know about be in control of the endpoint. But we'll figure that out later. What else do you have? He has nothing. That's all he cares about. We'll say fix me. Endpoint probably is driver specific. And so what does he want to do? He just says, I want to blast out reads. And so here he has a read packet is equal to USB packet data toggle is equal to data toggle. The address is 1 unconditionally right now, because that's how we have before. Endpoint also unconditionally 1. We'll have to fix this later. Which means here we can actually just leave these blank still. These guys all have to be public, so that we can modify them. What else do we have? We have PID is we are saying this is an input packet. And the buff, or the data, is a vector full of zeros that's 8 bytes long. Cool. Now, I guess in the service function, we could do this 2 ways. We could poll, like, say we have like 5 drivers. Each of the drivers could be polled at a rate and be passed in the USB service the USB handle as part of their service function. And they could tell someone how often they want to be pulled. I don't know if that really makes a lot of sense. The other option is that the USB system could be like mutex locked, so that we can handle multiple people trying to write to them at the same time. So I think that's probably what we'll do here is we will make this non-mutable and hold on to the USB system inside. I don't know. That's like not really like the rusty way to do it. I guess the real Rust way to do this normally would be that you have like a channel that you like send USB packets on. And since it's like single reader, multiple writer, everybody can just push shit onto it. And in his service loop, he would handle popping stuff out and queuing work. So maybe I'll do that. That seems reasonable. So we'll say USB-TX is a sender of USB packet, which means that we need to include the USB subsystem, or the utility class for that. So we'll say util async channel sender. And so now he needs a USB-TX as the sender of USB packets. Here he sends in USB-TX. Oh, but that actually also isn't great because we need to get the packet back. So what's the play there? Thinking. Let's think. I guess this like queue work thing is how it makes sense. You like return a future that says at some point I'll be done. The service function maybe handles that. Maybe I guess the real like the problem here is that I'm trying to run this like service loop as like a mutable with a mutable reference to self. I guess maybe the Rust way to do this is usually to split this out into like a separate structure. I wonder if that makes sense. So I wonder if I can say my service function is the only person that's going to have the UHCI device. When I queue work, I send that work over to the service function. He checks, and when he's done, he sets the future or something. I guess these guys don't actually... Does this guy even need a mutable reference? It looks like no. Looks like no. I'm pretty sure he doesn't, because all this guy's doing is he's shoving stuff into this like already mutex protected queue. No. Oh, I see. There's just all sorts of compiler errors that are causing problems that are blocking the mutability problems. One sec. Cargo check. We'll save this unimplemented for a second. Cargo check. He doesn't like that this is missing a semicolon. Cargo check. Yeah, here we go. So this guy does, in fact, need to be mutable. Oh, that's fucking annoying. Okay, so how do I dodge this? I need to think about... I haven't actually, like, figured out what the flow is going to be. I've just kind of been typing and hoping that it would come to me as I went, which sometimes happens, but sometimes does not. So this guy right now is, like, the guy who's, like, scanning for ports. The fact that UHCI needs like mutable references to do stuff makes a lot of sense because he's doing like sequences of work. Also, when you're doing like USB stuff, he's modifying the queue of work that has to happen. So it makes sense that that's single threaded. There's also something about the card also conflicting, but we'll think about that later. So the question is, how do we like get data into the USB queue and back out without needing multiple mutable references to that queue? And this sender receiver way makes sense, I think. We just have to make sure that we have a way to propagate info back. So I was gonna say that like if I send this packet off to the USB system and I say like, okay, all yours now, buddy. That means that I can have one mutable place, like one mutable reference that's handling queuing. And the only thing that we're missing now is like, well, I can't just forget about it. I need to get that data back. Which maybe starts looking like a like custom type. Instead of using like just a normal channel, we could implement a special queuing struct that will automatically pull the data back out. And that would look a lot like the USB feature that we have now. But his output wouldn't be a transfer descriptor. It would be a like USB packet. I think I like that. I'm gonna go to the washroom just for a second. I'll be right back. Give me like 2 minutes. Yo. Okay, yeah. I think that'll work. So I think that what we can do is we can make like a USB when we like queue these packets. Maybe we say here is a response. And this response is like a mutex, a shared reference to a mutex protected option of response, which is an awful type. But just give it a sec. So initially this will be none. But when the hardware finishes, we could lock this mutex and set the data inside. We would need to tell whoever is waiting for this that it is ready. So maybe this actually just gets wrapped into a new struct, which we'll call like USB response. And inside he has the mutex. But I guess this should be like a future of some form because I want to wait for him. I want to wait for this to get set. So he has a response. And I guess someone else needs to set him. So I guess this is just like a future promise. This is just like a classic future promise. Which I wonder if that like exists in the futures subsystem. Like for the futures like I don't know what to call it. But do they have like promise? One shot? Yeah. This is essentially the same thing. So they have a channel that can only take one setter. Which makes sense. So I guess what we want to do is we want to create a type that is a one-shot setter. Then we can like pass that in as part of the request. And the USB system can set it when he finishes. I like that. I like that. Okay. So I guess for now I'm just not going to do that. After saying that's what I wanted to do and I like it because I want to keep moving. So what we can actually do instead is when we queue work, we queue the work and we also say response tx is a async or is a sender of type vec u8. Okay. Then instead of that being instead of that being sorry, I need to go to bed. Thank you for the stream. I've really enjoyed it. Yeah, no problem, man. No problem. Instead of that being a return value for the work, it ends up being something like a handle that we can send something back in. And the other problem here is I don't want this to be a function on here anymore. We did say that we were going to have this be a sender of USB packets. And so I guess instead of a sender of USB packets, it's going to be a sender of USB packet and a sender of vec u8. Yeah. That seems reasonable. So here we need to double check that there aren't any problems here. So we're missing a bracket on the end. And here, this queue work function just no longer exists. Instead, in our USB service, first we forgot to send the devices out. So we'll say self.tx send USB device. We'll just say fix me USB device address. Not propagated. I guess we should just propagate it. Fuck it. So we'll say send address. This USB device needs to have an address. I think we need to await this. Yep. And then eventually we're now going to be like, once we've iterated our ports, we're assuming that our ports are all plugged in and on initialization. We're going to loop and try to pull in USB requests. So I guess maybe our USB packet will also have the receiver in it. I don't know. It's okay to have it separate. Fuck it. Use alloc vec, or I guess here we'll make a type for it. We'll say type USB packet request is equal to USB packet as well as a sender vec u8. What a life. And so now this is a sender of USB packet request or something. Okay. So here he has USB TX is a sender of USB packet request. This guy needs a way to pull out a sender, so we'll just say pub function takes an immutable reference to self, and he sends out a sender of USB packet request. This is no longer device channel. This is a packet requester. I don't know. We'll figure out the names later. And he returns. So this guy, it needs to be renamed from device RX and device TX. And now he has packet RX, which is a receiver of USB packet request. Great. Does my receiver have a way of constructing a sender? No, he does not. So I need to say packet TX is a sender of this guy. And I say device TX, device RX here, device RX here, device TX here. And then here, I do the same thing, but I say replace device with packet. These device with packet. And we pass these guys in. So packet TX, packet RX. Okay. Now the only thing we're missing here is that our packet TX is going to be self USB packet requester or something. And here we pass that in as packet TX. Cargo check. Does everything compile again? No, obviously not. Because at UHCI 556, I fucked something up for sure. Need to make this type public, probably. Cargo check. Oh, I spelled request wrong. So we'll just fix that up. And I didn't actually implement that, so this guy just has to say self.packet tx clone. Oh, does he not have a clone method? He should. I don't see any reason why he shouldn't. Oh, but I can only. I need to do t is clonable. No, that doesn't sound right. Why doesn't it like that? Method clone not found for this struct. Does not satisfy. Nothing is clonable. Oh, that's so stupid. Do I have to manually implement it? Simple clone for sender for all t's. Implement the function, and we say let inner is equal to self.0 inner arc clone it. And then we return self inner. Like, why was that not automatically implementable? Weird. I don't know why it didn't like that, but whatever. Now, just in the UHCI stuff, we were previously doing this like queue_work thing. We just nuke this queue_work thing. And instead, we do that over here. So first, we try to get some work. So we say self.packet_rx.receive.await. We map the work, and then we just send it back. So I think that here, we say work 0. And work 0 here. this should be data.len. Oh, oops. This should say packet. What did we have before? Why am I so confused? Oh, because before it was a vector of packets. Ah, okay. Sorry. So here, our packet request should be vec of packets and return a vector of buffers. Cool. That seems reasonable. That seems reasonable, because then the work is tied together. That makes sense. So we'll say work is this receive. We take some dot zeros in here. This guy is a vector of U8. Cool, and then we say work1 send finished work. There we go. Okay. And, oh, fuck, it's not compiling. 479. In mouse. No, in 497 main. Oh, it doesn't like that, Sure, I'll clone him. Easy. Okay, wait, I think that compiles. We're definitely pulling together a driver out of sticks and stones. Yeah, that's starting to look pretty good. Okay, so in our mouse service, now that we have a mouse, we can start constructing packets. We need to use alloc vec for this vector macro. Here, instead of generating a raw TD, we say self.usbtx send. So first we send the whole chunk of work. And then we say let txrx is equal to async channel. Again, we want to fix this type, but that's fine. And we just send as part of this a way for him to send something back to us. Then we rx.receive dot await. Let red is this, or let data, I guess. And we just print out data 0 buffer. I think that's it. So here we need to use async channel self. And this guy doesn't have a buffer field anymore. He's just the raw data. And here we have to set data toggle is equal to invert data toggle. We don't have this port iter anymore, I don't think. Nope. And wow, I wonder if that's getting close to being like a split out mouse driver. So we're not running this demo function, which means that we do need our UHCI stuff. I guess in USB, or sorry, in our USB structure, struct USB space. Before we do anything, the first thing that we do in our service loop is going to be initialize this. Oh, fuck. I did delete some stuff that we did need. So this port iter is still valid. Fuck. Okay, card check. Where am I missing? Okay, compiles. We're still compiling. Great. And I guess just when we start up our USB service, one of the first things that we're going to have to do is init UHCI. Which seems reasonable. Which means that this guy turns into init. And this guy, all of this stuff is going to have to turn into the port iterator. which I think means we just cut this out. Not sure. Let's think about this. Thinking. Ooh. So here we have port iter, who returns a UHCI port iter. Yeah, it seems reasonable. So we'll say our current iOS offset is, or let index is 0. Or sorry, usize. So we'll say our port offset is an IO offset new of 10 plus IDX times 2. Self.idx plus equals 1. If we say if self index is greater than 1, we return none. There's nothing to do. Because we're assuming that we only have 2 ports. This is also untrue. Note, spec allows for over 2 ports. Get over it. But we are only guaranteed 2. We may need to fix this later. Okay. Cool. Then these guys can be uncommented. And what does he do? Hold on. This loop where we're reading the mouse data, that stuff isn't happening here anymore. That's happening in the mouse driver. Setting address, I think, is done here? I don't remember. What do we expect from our port iterator? Here we set the address, so we don't have to do that here either. And we also do have to do this stuff. This should probably be done by the device. The device driver. Okay. We're starting to feel the right thing. So we'll say loop here because there's a chance that this fails. Otherwise, we return something. We found a port, baby. So here we do need a reference to the UHCI. So here we'll just say anywhere we have self in here, it's self.uhci because we're looking at the UHCI driver. Here we have a UHCI is a mutable reference to UHCI. So which means that this guy needs to have a lifetime called A, which means that this guy needs to say he has a lifetime called nothing. None of this is happening. But this is. And now we're actually in a problem again where we can't call async code from within this iterator, which it expects to be able to do because we want to be able to reset the port. So I guess what we'll do is we'll just do that here. Which isn't great. I'm not like really happy with that abstraction, but we'll live with it. You know what? I don't like this, like, this port iterator thing actually doesn't really make sense at all anymore. Really, we're just moving this loop up. Right? This is for port offset in this. We do this. Which is fine. It's just like, we just don't need that other thing anymore. If we still compile, we're pretty close, I think, to being in a runnable state. Yeah. I wonder what happens if we run. Are we gonna like slam into some unimplementeds? No. Okay, so the mouse, we're not getting any like logs about the mouse moving. That's kind of expected. Probably what we should do is start adding logs now to see what's happened and what hasn't. So here, maybe we go here and we say print line found device. Device or USB device has been found. Let's see what that does. So we never find the USB device. That's a good clue. Are we running the USB service? We are. So here we'll start logging stuff. We'll say info UHCI initialized. That happened. Oh, we here have to say if we reset the port. Haha, this only returns true if it's valid. So here we just say if we didn't reset, continue. I think that's probably what we were missing. Let's see. Oh yeah, here we go. Oh, baby! That's kind of sick. Okay, so do we think that this is a good abstraction? Maybe, maybe not. But we've definitely like got the bones in place for something, for like better splitting of work, right? Like from the mouse driver's perspective, he's not doing anything too crazy, right? But he is getting the mouse position, which is pretty fucking cool. There's definitely some cleanup to do here. Specifically, actually, what am I worried about? Oh, this like assert boot mouse, right? Like really we need to move this checking of whether or not this is a mouse out to the kernel. But I'm going to handle that in a bit, right? Because I think that what would be nice is if we could get to the end of this stream and at least see the mouse controlling the paddle at all. So I'm going to like bypass that for now and just write a fix me here and we'll say mouse, we should move the mouse check into the instantiation of the mouse driver or something in kernel main. Okay, so now what are we going to do with this data? We're going to like get the position and we're going to move the mouse. So every time we get the position, we're going to say, well, we'll start with the current position of the mouse. So we'll say position is XY, float normalized. We'll say probably like screen space will be 0 to 1. And we'll say here, we'll initialize the position as 0.5.5. Okay. Then we're gonna have some sort of sensitivity. I'll just make it compile time for now. Which is a float is going to be, well, we'll just make it 1.0 for now. We don't really know. I guess we do. We know that the maximum that the mouse can move at one given time is 255. So we should make this 1 over 255. And it should actually be much lower than this, 0.1 over 255. Because let's say that like the maximum movement, moving a full screen, that's actually pretty reasonable. And 255 is wrong, it's 1.7. Sorry, because signed integer or signed character. So we'll say let x movement is equal to data 1 dot something. What's the like? We're gonna cast this to a I8. We'll say y movement is the same thing, but data 2. He doesn't like that for some reason. Oh, because the data, right. This data 0. Sorry, these should be prefixed with zeros. Okay. let x movement is equal to x movement as f32 times sensitivity. And we'll do the same for y. And we'll say self.pause plus equals x movement and this is y movement, and we have to clamp it as well, so we'll say I think you can do like x movement like self.pause 0 clamp to 0.0 to 1.0. We'll say like you can't be more than like outside the screen, basically. Okay, and then here, instead of printing this, we'll print the position and see if that like turns into something reasonable. He doesn't like that we didn't put the position in here, so just write him down there. And let's take a little peek skis. Okay. Sensitivity is too high for sure. Let me out of here. So we're just gonna like maybe make this 20% of what it was before. So now I'm on the full left. Now I'm on the full right. Okay. Okay. So we're getting a position now, and maybe what we do is we say position tx is a sender of f32, f32. I'm not sure if this is how I want to structure it. Right? Like, maybe I want somebody else to pull the mouse, but for now, we'll just say here you send out self.pause, and anybody who cares will listen. And we'll say, we'll take in pause tx here as a sender of f32, f32. And the reason we want to do it this way is because that way we can construct the channel of who's going to get the position before we construct the mouse, which is a requirement here. Because here we're going to say, let mouse pause rx, or we'll say, yeah, mouse pause tx. Mouse pause rx is equal to async channel channel. So here we say mouse pause tx is passed to this guy, and here we'll say mouse pause rx goes in here. Now in our game we have mouse pause rx is a receiver of f32 f32, where he needs to import util async channel receiver. And this is then in our update loop, we'll say handle input needs to check the thing. So sorry, we need to store this guy as well. Here. Mouse pause rx like this. So here, we say, if the key was pressed, we have this, or let's say that the mouse overrides. So here, if the mouse moved, we say self dot mouse pause rx read. Not read, receive. We wait for something to happen. And we say match the mouse pause. We say if let pause is equal to some pause is equal to mouse pause. There we go. That's what I'm looking for. We say self.state paddle position is equal to the position x. And the paddle direction is equal to 0. And there's like a very real chance that that's good enough. So 501, we clone this to avoid some issues. And let's see if moving the mouse moves the paddle now. So he's mad about something. I don't know how all of a sudden we're no longer receiving mouse events. Oh, we did just stop printing them, so that's probably related. So let's go back to the mouse class and see. Oh, we just didn't weigh this. So we're idiots. Oh, hey, that's pretty sick. Now, it's laggy as fuck, but I am controlling the paddle with the mouse, which is fucking sick. Look at that. Look at that. Let's go, baby. Oh, that's so sick. Okay, so there's some very obvious problems here, and I'm not really sure how happy I am with the way it's been implemented. But we've at least like stubbed something out to iterate on later, which is very sick. And the keyboard still works. Mouse, keyboard. Very cool. Okay. So while I'm not really happy with the current state, we have actually like implemented a lot, right? We've just like gone from having everything integrated into one spot into having like some like idea of what our abstractions are going to look like. We have like the mouse who talks to the USB system. The USB system like lazy initializes stuff based off of what it sees on the ports. We know how that we like want to do some sort of like matching of device IDs as part of the construction. We know that we have like ways to pass devices around. And we're starting to see like what the data flow is going to look like, right? We kind of understand that the USB system is going to have to like get stuff and return stuff to callers. We know that we want to implement like a data structure that's a one-time response, like a promise. And I think that I'm pretty confident that I don't like the way that we're passing data between the game and the mouse driver right now, where I'm going to have to think about what that's supposed to look like. But we have something that works, right? That's pretty fucking sick. Pretty sick. Yeah. So thanks for watching. If you liked what you saw, I stream most days around 1 or 2 o'clock Pacific time, and I stream for like probably between 1 or 2 hours. I try not to go much over 2 hours because it makes for too much if you're going to watch the VOD later. All VODs go to YouTube, so if you're watching live and you miss, there's a YouTube link in the Twitch description. And if you're watching on YouTube and you want to pop in, say hi, ask questions, whatever, there should be a Twitch link in the YouTube description. All code eventually in like a cleaned up state ends up on my GitHub. So if you want to go poke around, there's a Stream OS repository under my username, which is the same on Twitch, YouTube, and GitHub. Yeah, thanks for watching. Catch you on the next one. Bye!